Okay. My presentation is about hardware technology and technologies. So are you right? Okay. So today I'd like to talk about the resource disaggregated platform, including Power8 and GPUs for diverse cloud computing service. My name is Takashi Yoshikawa from NEC. First of all, I'd like to show you the resource disaggregated platform in service. It has been in service as one of the high-performance computing system of the Cyber Media Center in the Osaka University. It consists of 64 servers and 70 devices in resource pool over 6 racks. And it provides computing power, GPU computing power to the researchers and students in the Osaka University, as well as other universities in Japan. So it is a multi-rack scale and software-defined high-performance computing system. We can build up a physical computer system by, along with the user's requirement, by attaching PCI Express devices from the resource pool. And if the task is completed, those devices can be put back to the resource pool, so we can share expensive devices like GPU. And so as a result, it is a very cost-effective implementation of the GPU high-performance computing in the cloud data center. So to make the resource disaggregated system, the most important technology is interconnect fabric. We have developed the ExpEther. ExpEther is the PCI Express over Ethernet technology. I will explain 3 key features of the ExpEther. The first one is distributed PCI Express switch architecture. With this architecture, we can make a standard PCI Express switch with a connection distance of a few kilometers and the port count of 1,000. So please look at the figure in the left. It shows the standard PCI Express switch chip. Inside the switch chip, there is an upstream PCI bridge and downstream PCI bridge, and they are connected through the chip internal bus. We separate those PCI bridges at the chip internal bus and exchange this chip internal bus to the Ethernet. Actually, we implemented each PCI bridge into a single chip with Ethernet encapsulating function. So that chip is the ExpEther chip. So the combination of the ExpEther chip and Ethernet switch is completely equivalent to the standard single hop PCI Express switch. So the second key feature of the ExpEther is reliable Ethernet. We can implement congestion control and retry mechanism into the ExpEther chip to make the end-to-end path completely reliable. We also developed the multipath technology. By using multipath technology, we transfer a single data stream by using multiple of the paths. So we can make we implemented dual path, so we can double the bandwidth, and also we can make the end-to-end path redundant and reliable. This multipath technology is also useful to match the bandwidth of the PCI Express and Ethernet. The third key feature is the software-based device attachment control of the ExpEther management software. By using ExpEther, we can connect a lot of hosts and devices into a single network. After that, PCI Express tree is automatically constructed among the ExpEther chip having the same group ID number. For example, this green host and green devices have the group ID number 1 in common. So the PCI Express tree is automatically constructed, and then those green host and devices can be operated as a conventional computer. And ExpEther manager in the remote server can change the group ID of this device I from the group ID of number 1 to number 2. Then this device is removed from the green host and then hot plugged into the red host according to the PCI Express standard hot plug procedure. Okay, so we have developed OpenStack-based system resource management software by using the REST API of the ExpEther manager. Actually, we modified Ironic module, which originally controls the bare metal, virtual machine, to control the physical device in the PCI Express level. So this shows the implementation lineup. There are 3 generations of the ExpEther chip. In terms of the Ethernet interface, we have 1 gigabit Ethernet and 10 gigabit Ethernet. And those chips are implemented into the host bus adapter card and expansion box. And these are quite new ones. It has PCI Express Gen 3 by 8 and dual 40 gigabit Ethernet. So it can afford to connect high performance accelerators to the power servers. So we built up the experimental setup by using commercially available hardware products. The ExpEther HBA host bus adapter card is installed into the Power8 server of the Taiwan Habanero, and NVIDIA K8 and Intel P3700 SSD are mounted on the ExpEther expansion unit. And they are connected through the standard 40 gigabit Ethernet switch of Mellanox. As I mentioned, the logical software view is just a PCI Express switch. It is a pair of upstream PCI bridge and downstream PCI bridge. Ethernet is transparent, so that's why we can build up the experimental setup by using commercial products without any modification. So it's very early stage of the experimental. So far, we get the data from the CUDA N-body benchmark. And blue one shows the, blue one is for the K80 in the local PCI Express slot, and the red one is for the resource disaggregated platform. As you can see, we can get comparable performance. This is why, it is because the ExpEther chip, all the function of the ExpEther is implemented into a hardware single chip, and the latency is only 400 nanoseconds. So probably the interesting application for the resource disaggregated system is multi-GPU system. Because all the GPUs are local, so we can expect, all the GPUs are local and data transfer is direct memory access. So we can expect high performance, and also we can expect the high, scale up of the performance along with the number of the GPUs. We work with Professor Amano in the Keio University with this work. So, but using ExpEther, using our resource disaggregated platform, we cannot enjoy the full performance of the GPU because there is the latency of the Ethernet. So how the latency affects the performance is depend on the data transfer, data communication model in the application process. So the less communication type application, for example, the particle motion simulation of in the large scale particles, there is only 2 times communication with a bunch of GPU processing iterations. So for such application, we can easily get the scale up of the performance along with the number of the GPUs. So the scaling up is almost proportional to the number of the GPUs. For the rich communication type application, we successfully masked the latency by overlapping the data communication and GPU processing, and then we get the scale up ability with the number of the GPU for the graph search problems. These results shows that using multiple of the GPUs from the resource pool is effective to make the simulation and calculation time short. And for another application for the resource disaggregated platform is the high performance, high speed storage system using NVMe device. So this shows the benchmark result of the IOPS on the Power8 platform. And we get the IOPS of 460K at the block size of the 4K. And this value is almost the same for the local SSD and also the product specs. So by using resource disaggregated system, we have developed a resource disaggregated store. We call it RD store. RD store is a key value store software making use of the resource disaggregation. It allocates data not in the local storage, but in the NVMe storage in the external NVMe storage. And those external NVMe storage is shared by using the function of the ExpEther. So by using ExpEther, SRIOV compliant device can be shared from the MR, from the multiple of the host. So the RD store has the scale-up ability for both CPU, control CPU, and storage device individually. And also, all that data transfer is DMA, direct memory access. So it is high performance, as well as having the unique scale-up ability. So that's the end of my talk. So resource disaggregated platform is cost-effective implementation of the GPU high-performance compute power in the cloud data center. And the latest Gen 3 by 8 2 by 40 gigabit Ethernet ExpEther with the combination of the Power8 server show potential for intensive computing. So that's all.